In this video, we're going to show you how to rationalize the denominator. What that means is the denominator, if it has a radical, you're going to turn it into a rational number. The square root of 3, for example, if you were to type it into your calculator and press enter, you get some never-ending decimal number. We call that a rational. It never repeats and it never ends. So to make the denominator rational, we need to multiply this fraction by a fraction of value 1. And the number we choose for the top and bottom is actually going to be whatever the denominator is. So in this case, we have a denominator of square root 3. That means we're going to multiply the fraction by square root 3 over square root 3. First of all, we're allowed to do this because this is equal to 1. So I'm not actually changing the number itself. I'm just changing the way it looks. Secondly, we chose the number square root 3 over square root 3 for the top and bottom because these two numbers, when you multiply them together, creates a denominator of just 3. Because the square root of 3 times the square root of 3 is essentially the square root of 3 squared. And that turns into just 3. And that's the whole idea. 3 is a rational number, hence we've rationalized the denominator. The top here, 7 times root 3, can't be simplified. And check to see if 7 over 3 can be simplified. In this case, it can't. So you're going to leave it as 7 root 3 over 3. And 3 is now a rational number, so therefore I've rationalized the denominator. This example here, number 2, where we have two radicals, the process is still the same. You're going to try and change this number in the denominator to a rational number. So we're going to multiply the top and bottom by square root 15. Use the denominator for both the top and bottom when you multiply. So what that does to the bottom, the denominator is going to turn into a 15. Square root of 15 times the square root of 15 is 15. On top, you're going to have 3 root 7 times root 15. So that's going to turn into 7 times 15. It's 70 plus 35, 105. Alright, double check to see if the radical can be simplified. Is there a perfect square that goes into 105? So start at 100, divide 81, 64, 49, 36, and so on. And you'll find out when you go down the list of perfect squares that it cannot be simplified. So this is going to stay as is. Check to see if the numbers on the outside of a radical, though, 3 over 15, can be simplified. In this case, they can. 3 over 15 is going to turn into 1/5. So I can write 1 times 1 square root of 105 over 5, or you can just write it as the square root of 105 over 5. It doesn't actually matter which one you write. This one you're going to see more often, though, as an example or a problem, rather than this one's a little bit less standard written. Let's do one more example. Example 3, we have 5 over square root 18. So we're going to multiply both the top and bottom by square root 18. It's very important that you do it to both the numerator and denominator. If you do it to one or the other, you're actually changing the number, and you can't do that. We want to keep this number value the same, just change the way it looks. So on the top, you're going to have 5 times root 18. You can't do 5 times 18 because one number is inside the radical, one number is not. Square root of 18 times the square root of 18 is just 18. 5 over 18 can't be simplified, but double check the square root of 18 to see if there's any perfect squares hiding in there. And it turns out there actually is. 9 times 2 is 18. So what you can do is split 18 up into 9 times 2. Square root 9 turns into 3. So this number was on the inside, but once I square rooted it to get 3, I moved to the outside. Now I have 5 times 3, square root 2 over 18. This right here, 3 and 18, you can simplify. 3 goes into 3 once. 3 goes into 18 6 times. So this is going to turn into 5 root 2 over 6. So this turns into a 1. The 18 turns into a 6. 5, 6 can't be simplified. Root 2 can't be simplified. You have now simplified the entire fraction. So just one more time, when you rationalize the denominator, simply choose the denominator of the given fraction, multiply both the top and bottom of the fraction by that radical, and what that'll do for you is it'll cancel out the radicals and make the denominator a rational number. In this case 3, this case 5, and this case 6. Those are all rational numbers. Once you have that, do any more simplifications you need to, whether it's with a radical or with the numbers on the outside of the radical, the fraction itself. And then once you're done, box in your answer.